You've ever thought about an add-on laser system for your 3D printer or CNC machine? Let's take a look at this Endurance Laser 10 Plus system from George Formachev. Something you're interested in? Stay tuned. It's coming up. This is the Endurance Laser 10 Plus my way. I decided I wanted to make a few changes to the existing unit that I received in the mail, and what I'm going to show you really quick is what I did to get this to this point. This is not what you're going to see in the box. I'm showing you what I did very quickly to get it to this point. The head has been modified, the laser head itself, all wires have been sleeved, and the laser box has been redesigned the way I wanted it. The first thing we're going to do is pull the laser box down, and it's very simple. It now employs 6 plugs. You simply unplug 1, 2, 3. There's another one in there, and your power up here. And this plug, and now you'll see that the laser itself is totally detached from the laser box. The laser box is held in place with neodymium magnets for easy removal. I wanted a toolless removal for both the laser box and the laser head itself, and we'll go down to the laser head shortly and take a look at that. And all you do is take the box off and you're done. No tools. Let's go over the box a little bit and I'll show you what I did to it. The box on the left, the white one, you can see was the original box that I received in the kit. Actually, it wasn't a kit, everything was assembled, but I wanted to make this box larger, or it needed to be larger. By the time when I opened this up and looked at the wiring inside, in order for me to get it in any kind of neat fashion, this box needed to be redone. So it is 10 millimeters taller and 5 wider. You can see the size difference here, and I needed every inch of that. Also, on the original box, the wires that you see coming through here were hard mounted to the laser itself, so you cannot remove the laser without removing this box as one whole unit, and I wanted to mitigate that. I wanted, if I want to leave this laser box up here, and I wanted to do that with this existing design, that wasn't possible. Also, I've added, if you look at this one here, this is the laser now. It used to be up here, so the laser and amperage remains the same, but this, I added another voltage and amperage display and a temp controller with a set point. There's a video by Ham RX8. I'll post a link to that video. He does an outstanding job in his way on how he went about putting this laser together. This was just the temperature itself, but now I get the current temperature, the current temperature and what it's coming down to, or the temperature as it's lowering. So once it hits that set point, this will shut the tech cooler off. And when the tech cooler comes on, the voltage, you're going to see a drop here, and that is the voltage that the tech cooler is running at. And the amperage you're going to see here is what the tech cooler is pulling, not system amperage. The other amperage here will be for the laser itself. And I'm using one power supply. I decided not to use 2. I'm using one 30 amp power supply. It supplies this whole box. And if you look on the side here, this is how I redesigned the box. The Arduino here, I don't think I'll ever use that, but it came with the board. It's actually mounted on a sled. In this box, it was tie wrapped to the bottom. You just simply remove the screw and you can move the sled out of the way so you can get to any other wiring underneath. So you have your TTL, your fans, your main power coming in up here, which is a 14 gauge, your laser itself, tech cooling, and temp, which are all of these plugs marked that plug into this box. To hold it on, neodymium magnets, again 3D printed, and they center on these magnets themselves so the box doesn't slide one way or the other. It actually sits square on there. Another thing I didn't really particularly care about with this box is that the fan was just mounted right here. The fan is now pulling through these vent slots. That is decreasing efficiency in my eyes. So actually, when I redesigned the box, there is actually a fan hole or a mount with a hole in it for this. All the screws on this box itself are 3mm. So there's not a hodgepodge of different size screws. This was a big deal to me, and that was to add the on and off switch. When I turn power on to the power supply up there, and we'll get to that shortly, quickly. I don't want this box to turn on, or I want to be able to turn it off from here. So I added another switch. It's a lit 12 volts. This one remains the same, which is this is 100% power. Oops. And off. And then center here is laser off. The up position is TTL. And the down is Arduino, if you were using that, which I am not. So there's a little look at the box itself. And also, incidentally, the DC-DC converter in this box was just screwed to the bottom. In this one, it actually has a standoff designed into the box that mounts with 3mm screws. So let's move on and take a look at the laser and how to get it off. So here we are, we're down at the laser itself again, toolless. I did not want to have to look for Allen wrenches. I don't want to have to look for anything. I wanted, and my idea was to be able to remove this assembly as a unit without having to use tools. Again, this utilizes the CNC router parts 80mm spindle mount, and they actually have a 5/16 18 screw hole tapped in here, and it's used either for a jack screw. If you tightened it too much and your spindle won't come out, you run a screw in there and it will jack this space out here so that the spindle has clearance, or you can use it for a dust chute. So in my thinking, I'm like, why don't I go ahead and utilize that, because that puts me at the center of the spindle and I don't have to drill anything. I don't have to make anything else. This is just a typical wing nut with a thread. Basically, it's an all thread. Probably make one of these, but they sell them again at Home Depot. It has a washer, and as you can see, I didn't make this, but it works perfect. So you just take that out, and this was designed, again, 3D printed. All you have to do is loosen up these wing nuts. I'm not going to do the other one because this will kind of like fall off of here. I have to support that, and I'm one hand in that. Just loosen one on that side, loosen the other on this side, and basically this unit just slides off this way, You just need to loosen it up so you have clearance so that this ledge, which is your centering and squaring ledge, slides out past this, and this whole assembly slides down. I'll see if I can get this to hold up. I'll loosen the other side, and then we'll come back and see if I can just show you how that works. Alright, so when I drew this up and printed it, it does have a little bit of interference fit. Excuse me. So all you need to do is just slide this off, slide it that way, and your laser drops off just like that. I don't want to drop that, but I'm kind of one-handing that, but you see how that works. It has the pinch tight mount. This thing doesn't budge. If you're wondering, I mean, it doesn't move whatsoever. I'm not going to have any problem with wobbling or shaking or anything like that with that mount design. And all it is basically a 1/8 inch cut to fit, and it goes down the center here. If you look at the bottom here, you can see the original mount screws that were already threaded and provided in the housing of the original laser itself. So that's what these are for. Again, there's a 3mm 3D printed. Again, L channel, Home Depot stuff, or your home center, whatever country you're looking at. If you're in the United States, get it there. This I had to cut down on the table saw just for the dimensions, because they're not a standard dimension based on the design of this and what I did to it. So that is how the mount works. Pretty simple, but very effective. A big upgrade to this is the cooling. And on that one, let's take a look at that. Back on this, and let's look at the cooling. This is the biggest issue I had with this laser, and that was the stock cooling that was on here. For me, that was not effective. It gets really warm in my garage here in California. Right now we're probably looking at 100 degrees. Originally there's a fan on top of this. The bottom was open, and this CPU fan, which they're very effective, they do work, but when I really looked at this, I'm like, that's a very small area to pull heat off of that tech cooler, and it wasn't working for me. I was excited to plug this in. When I plugged it in, I was amazed that the temperature came up to ambient temperature. I'm like, that's not supposed to be happening. So I thought, what could be causing that? And it's simple. You cannot have an open bottom or an open door on a refrigerator and cool it. And basically what you're doing is you're pulling hot air through your refrigerator by putting a fan up here. And this thing was going, if it was 22C in here, or 25, or 30, or 40, whatever it was, this was going to come up to that temperature, because this fan is pulling hot air past that laser itself. So, I said, let me think about what I can do. Here's what I did. I removed this fan. I removed the tech cooling off of this adapter plug. It has its own now, which comes up, and it's the red one, I believe, here. The temp is this one, so they're all on their own plugs. The only fan that this plug runs right now is this, I don't want to say a specialized, but it's a 50 CFM thin fan, 90 millimeters. The only way I could seem to make this work, or was the easiest way, because I don't have a milling machine, I can't do what Ham RX-8 did. So I had to do what was within my means and going to be effective. This is a all over eBay 100 by 100 millimeter by 18, I think it's either 18 or 19 millimeter high heatsink. And that fits, almost fits a 90 millimeter fan. So you can see where the holes are center drill, or well, not center drill, but they're drilled through, and then the bolts come through the back side and they're held there. They're a little bit longer because I originally had a bigger fan on here. I'm not going to shorten these in case I decided to go with that, or a thicker fan, but I'm going to leave those there where they are. They're fine. This fan here is a ball bearing fan. It is not a sleeved fan. So it's a high efficiency fan. I'll post links to all of this stuff that I'm talking about here. So it's all over eBay, or you can find it yourself. But I'll post links to that. The biggest thing and the biggest difference that was made for me was installing a refrigerator box around here. If you look at this, you will see a surround around the original laser module. And in between that, it's, I believe, 3/16 thick, or it's close to 5 millimeters foam. Got out the trusty old laser, not laser, but hot wire foam cutter. I knew I built that thing for a reason. And cut foam sheets. And I'll pull this bottom off. This one's press fit. The one on the top has screws, and it utilizes the existing screw hole pattern that was there for the fan, but now it just holds the top on. This I want to come off because this utilizes the 8 millimeter spacer. Again, Ham RX-8. I got that idea from him, so I made one, and without a lathe, mind you. It can be done without a lathe. If anybody's interested, I'll post a short video on how I did that, and it's actually pretty simple. 8 millimeters. And I'll also, if I make that video, I'll post a link where I got the 9 millimeter laser frame. You need a laser frame. You don't need to buy a laser lens and then take the lens out. If you're gonna do that, use the lens. Just get a frame, an empty frame. That's what I did. And that screws right in there, and the dimensions are exactly to his. So, let me pull the bottom off of this real quick. I don't want to get this video too long. This is my third iteration of this video, and I don't want anybody to get bored. So let me pull that bottom off real quick, and I'll show you what the insulation looks like around it. So there you go. You can see it. Just foam sheets. And I used clear packing tape like around the edges, so it's like a box. Very easy to remove. Again, L channel holds these on. These are held on with 3 millimeter button heads. So everything is easy to remove. And then there's a close-up of the spacer itself. It's kind of like a home knurling job, but I wanted to put that on there so if it gets stuck, I have something to grip on. I'm not trying to grip on shiny aluminum. So that's the laser head itself. Again, at this point, the lowest temperature with this setup at, I believe, 75 degrees Fahrenheit that I was able to pull was 2.9 C. If this is in the winter, this will freeze. But your ambient temperature outside determines your max low temperature that you're going to be able to get off of this. You can see here where the fan was pulling hot air up and out of the top. past this. That's not going to work. Didn't work for me. My design works. Let's move on real quick to the laser power supply, and we'll take a quick look at the controller, which is a simple switch, and how I put on the air assist. I'm not utilizing the air assist that was sent with this. I wanted to use infrastructure that was already there, and I think it's going to work out great. And then we'll close this video. Let's take a look. So down to the controller very quickly. A new switch was added. This switch is 120 with a pilot light. Again, nothing can be powered on this box unless this main power is on. That's off. The only thing, I believe you can turn the 5-volt on, but I want that so I can synchronize Mach 3. That's the reason why that does that, and it's not on this. But very simple. Comes out through the back on a aviation plug, and ends up here at the coming through the cable chains to the 12-volt, and then the 14 gauge runs from here up to there. Why did I do that? Voltage drop was too great trying to come from the controller itself, and the more I thought about it, this needs its own power supply. This says potentially can pull probably 7 or 8 amps between the set cooler and the laser, and I want it to have its own power supply. So when I hit the switch, it turns this on. I had room to mount it in the cable tray, or cable chain tray, which was a good thing. Other than that, I wasn't sure where I was going to put that, because I need everything to travel with this machine. I have a very large area. So it's a 4x4, so it's pretty much 4 feet by 4 feet if I wanted to do something that large, and I can't have adapters or anything else dragging around, so that's where that's mounted. Let's go on to the table real quick and look at the air assist. We'll go up top. I'll show you what I did with that, and we'll close this video. So for the air assist, the pump was mounted on the frame of the CNC machine just down here on the back side in its own little cubby hole, and it's plugged into what would normally be my vacuum. So if I'm not plugging the vacuum in, I just plug this in. So when I switch the switch on the front, it turns that on, then the line just comes up and around through here. Pretty simple thing here, and if you look at, I split this off from the solenoid from the regulator itself, and I just turn the valve on. If I'm not going to use it, turn it off. If I wanted to use the air compressor that way, or if I wanted to use the air compressor for the air assist on this, just leave this off and use the air compressor. So the air just comes up to this existing tool, air blast tool, cooling hose here. There's plenty of room to get down to that. If it doesn't work, we'll see what happens. This is the system all fired up. You can hear it running. See what it looks like. The only thing I need to come up with is I have some ideas on how I'm going to do fume extraction. That will be in a future video, but other than that, that's how I installed the Endurance 10 Plus laser. I'm not going to go over Mach 3. I can also do that in a short video if anybody's interested. How I got that to come on and work with TTL. I will post links to everything I talked about. The pump here, I don't suggest you order that with your kit if you live in the United States, Canada, or any other country that uses 120 volts. This is 240. I didn't read the fine print. That's what it said. So I can't use this. I'm not going to plug this into my dryer plug, obviously. So also the adapters, I would recommend you bypass those unless you live in Europe or a country that utilizes 240. It will switch to 120, but they get very hot. These are 20 bucks, $30. You get a Meanwell NES, higher efficiency, run you about 40 bucks. I suggest you do that, but that's up to you. So we're going to close this video. Please like, comment, subscribe. If you have any questions concerning the installation of this unit, drop it in the comments and I'll get back to you as always. And once again, thanks for watching.